In this video, we're going to talk about graphing quadratics. So our first thing is to understand the parent graph of a quadratic, x squared. And so what we know about the parent function is the pattern here is, and we could look at this if we had a table. When I input 1, 1 squared is 1. When I input 2, 2 squared is 4. So over 1, up 1, over 2, up 4. And that pattern maintains so in the parabolic feature of the graph. So looking at this, first off, let's understand the domain and range of this function. Domain is defined as x such that x is an element of all real numbers, and range for the parent graph is defined as y such that y is greater than or equal to 0, which we can see visually on this graph. So a couple things to recall are the transformations of a function. So given some function, different values for different coefficients in that function. And this is for all function types, not just quadratics. When I have a leading coefficient of a less than 0, an x-axis reflection. When b is less than 0, so it's negative, I have a y-axis reflection. When the absolute value of a is greater than 1, that's a vertical stretch. When it's between 1 and 0, that's a vertical compression. And then, of course, a translation right-left is based on c. But it's important to remember inside the argument is opposite of how we're thinking about it. So if we have minus c, that moves us right, whereas plus c would move us left. And then that d coefficient would translate up or down. So let's look at some examples. The very first example we're going to do is graphing 3x squared minus 2. And so looking what we know here, we translate to the down 2 units. And we have a vertical stretch of 3 units. Now it's important to make sure that we stretch first, which we know based on the parent graph we're centered at the vertex. We could go ahead and stretch it and then translate, but since my vertex is at the origin 0, 0, it is not impacted by a vertical stretch or compression, so I'm going to go ahead and translate it down 2 units. And the reason I know this is down 2 units and not to the right is because it's outside of the argument. It's not contained with the x and the squared. So then as I'm building this parabola, if it's a vertical stretch of 3, when I go over 1, instead of going up 1 like the parent graph, I'm going to go up 3 units. And and over 2, I'm going to go up 12, which on this graph is not on the axis. So you want to make sure that you really can have that parabolic motion. You don't want to have a V. I mean, that just looks like absolute value. And so then how does the domain and range affect it here? Domain is x such that x is an element of all real numbers still. And you'll find that in most cases that is always the case unless the parabola is reflected over the line y equals x, which then doesn't become a function. And then the range is defined as y such that y values are greater than or equal to a negative 2. So then let's look at our next example. Our next example has us graph y is equal to negative quantity x minus 3 squared. And so what this does is this reflects over the x-axis and then translates to the right 3. So if I translate right 3 for my vertex, as I build my parabola, instead of going over 1 up 1, I go over 1 down 1 because of that x-axis reflection, over 2 down 4. And then for domain and range here, again, domain is defined as x such that x is an element of all real numbers, and the range is defined as y such that y is less than or equal to 0, which is interesting because we did not translate up or down, therefore domain and range does stay the same. However, our graph is different from the parent function. Thanks for watching.